Titan is not just another moon. At first glance, it looks strangely familiar, a world shaped by rivers, lakes, clouds, and rain. Its surface is carved by flowing liquids, its skies filled with thick clouds, and its landscape shaped by weather patterns that feel almost Earth-like. In many ways, Titan is the only place beyond our planet where liquids actively shape the surface today. But nothing here is what it seems, because on Titan, the rivers are not made of water, the lakes are not filled with oceans, and the rain that falls from its skies is not part of the cycle that sustains life on Earth. Instead, this world runs on an entirely different chemistry. Titan is a place where methane and ethane flow across the landscape like water, where temperatures are so cold that ice behaves like rock, and where sunlight is filtered through a dense orange haze that hides the surface beneath a permanent twilight. It is familiar in shape, but alien in substance, a world that feels like a distorted reflection of Earth. For centuries, Titan was little more than a mystery, a faint orange dot orbiting Saturn, its surface completely hidden beneath thick clouds. Unlike most moons, which reveal their landscapes easily, Titan refused to show what lay beneath its atmosphere. It remained one of the last unexplored worlds in the solar system, its true nature concealed behind layers of haze. But when spacecraft finally pierced that haze, what they found was unexpected. Beneath the clouds was a landscape that looked uncannily familiar. Coastlines, channels, and vast dark seas stretching across the surface. Yet every detail revealed a world governed by different rules, where chemistry and physics combine to create an environment unlike anywhere else we know. Titan is often described as one of the most Earth-like worlds beyond our planet. But it is also one of the most alien, because while its landscapes may remind us of home, the reality of Titan is a world shaped by extreme cold, complex chemistry, and an atmosphere so thick that standing on its surface would feel more like being at the bottom of an ocean than under an open sky. To understand why Titan might be the strangest world in the solar system, we have to start by looking at what it really is. Not just a moon, but a world in its own right, hidden for centuries beneath a veil of haze. For most of human history, Titan remained an enigma. Even as telescopes improved and astronomers began mapping the moons of the outer planets, Titan refused to reveal its surface. Instead of craters or ice plains, observers saw only a soft orange glow, a thick atmosphere scattering sunlight and hiding whatever lay beneath. When the Voyager spacecraft flew past Saturn in the early 1980s, they confirmed what scientists had long suspected. Titan was wrapped in a dense blanket of haze, far thicker than anything found on other moons. But even Voyager could not see through it clearly, leaving Titan's surface a mystery. It wasn't until the arrival of the Cassini spacecraft decades later that Titan finally began to reveal its secrets. Using radar capable of penetrating the thick atmosphere, Cassini mapped the surface for the first time, uncovering a world that looked surprisingly familiar. Networks of channels stretching across the terrain, dark patches resembling seas, and vast plains shaped by flowing liquids. The Huygens probe, carried by Cassini, descended through Titan's atmosphere in 2005, becoming the first spacecraft to land on a moon in the outer solar system. As it fell through the haze, its cameras captured images of branching channels and rounded pebbles scattered across the surface, evidence that liquids had once flowed there. What Huygens revealed was remarkable. Titan is not a small moon. It is larger than the planet Mercury and only slightly smaller than Mars, making it one of the largest moons in the solar system. Its thick atmosphere is composed primarily of nitrogen, the same gas that dominates Earth's atmosphere, but mixed with methane and other hydrocarbons that give Titan its distinctive orange color. This dense atmosphere creates surface pressure about 50% higher than Earth's, meaning that standing on Titan would feel like being deep underwater, surrounded by a heavy, hazy sky. Sunlight barely penetrates the thick clouds, casting the surface in a dim amber glow. Unlike most moons, Titan is geologically and chemically active. Its surface is constantly shaped by atmospheric processes, erosion, and possibly even internal activity. It behaves less like a frozen satellite and more like a small planet, a complex world with weather, landscapes, and dynamic processes that continue to evolve. And it is this combination of familiar features and alien chemistry that makes Titan so unique. Because once scientists began mapping its surface, they realized that the processes shaping Titan looked strikingly similar to those on Earth, except for one critical difference. On Titan, the liquids that flow across the surface are not water. Instead, Titan's rivers and lakes are made of liquid methane and ethane, hydrocarbons that exist as gases on Earth but become liquids in Titan's extreme cold. With surface temperatures hovering around -180 degrees Celsius, water is frozen solid, forming the bedrock of the landscape, while methane behaves like water does on our planet. This creates an alien version of Earth's hydrological cycle. Methane evaporates from Titan's seas, forms clouds in the thick atmosphere, and eventually falls back to the surface as rain. That rain carves channels into the icy ground, filling lakes and flowing into vast basins that resemble oceans when viewed from orbit. Some of these seas are enormous. Kraken Mare, Titan's largest sea, stretches hundreds of miles across its northern hemisphere, with shorelines and inlets that look strikingly similar to coastlines on Earth. Radar observations have revealed smooth surfaces and wave-like patterns, suggesting that Titan's seas are not static pools, but dynamic bodies of liquid shaped by winds and tides. The similarities to Earth are striking, yet the differences are profound. Instead of water droplets, methane rain falls slowly through the dense atmosphere, sometimes forming storms that reshape the surface over time. Instead of rock and soil, Titan's rivers carve through a crust of frozen water ice, sculpting valleys and channels in a landscape where ice behaves like stone. Standing on Titan's surface, if it were possible, you might see dark rivers winding through pale plains, distant hills softened by haze, and a dim sky glowing faintly orange above you. The air would feel thick, the horizon blurred, and the landscape eerily familiar, yet completely alien. These liquid hydrocarbons are not just shaping Titan's surface, they are constantly cycling between the atmosphere and the ground, creating weather patterns that resemble those on Earth in form, but not in substance. And this methane cycle is only possible because Titan's atmosphere is unlike that of any other moon. Thick, layered, and rich in complex chemistry that continues to evolve over time. Titan's atmosphere is one of the most chemically complex environments in the solar system. Dominated by nitrogen, much like Earth's atmosphere, it also contains significant amounts of methane and a wide variety of organic molecules formed through chemical reactions driven by sunlight and charged particles from Saturn's magnetic field. High above the surface, ultraviolet radiation breaks apart methane molecules, triggering chains of reactions that build increasingly complex hydrocarbons. These reactions produce a thick haze of tiny particles that slowly settle toward the surface, giving Titan its distinctive orange color and constantly coating the landscape with organic material. This atmospheric chemistry is sometimes compared to what scientists believe may have existed on early Earth billions of years ago, before oxygen became abundant in our atmosphere. Titan, in a sense, may offer a glimpse into a world where the building blocks of life form naturally through chemical processes occurring on a planetary scale. But Titan is far colder than early Earth ever was. At such low temperatures, chemical reactions proceed slowly, and liquid water, considered essential for life as we know it, exists only as rock-hard ice at the surface. Despite this, the presence of complex organic molecules makes Titan one of the most intriguing environments for studying prebiotic chemistry beyond Earth. As these particles fall through the atmosphere, they accumulate on the surface, interacting with liquids and shaping Titan's landscape over time. The result is a world where chemistry, weather, and geology are deeply interconnected, creating an environment that feels both active and ancient at the same time. Yet the surface chemistry is only part of Titan's story, because beneath its icy crust, evidence suggests that Titan may hide something even more remarkable: a vast ocean of liquid water locked away beneath layers of ice, warmed by internal heat deep within the moon. Beneath Titan's frozen surface lies evidence of a hidden ocean, a global layer of liquid water mixed with ammonia, trapped beneath a thick shell of ice. This ocean is thought to exist hundreds of miles below the surface, warmed by residual heat left over from Titan's formation, and possibly by tidal forces generated through its interaction with Saturn. Scientists first suspected this hidden ocean after observing how Titan responds to Saturn's gravitational pull. Subtle changes in the moon's rotation and shape suggest that its outer shell is not entirely rigid, but floats above a softer, fluid layer beneath. These measurements indicate that Titan's interior is not frozen solid, but layered, with a liquid ocean separating the icy crust from a deeper rocky core. If this ocean exists, it would be one of the largest bodies of liquid water in the solar system, potentially containing more water than all of Earth's oceans combined. But unlike the methane lakes on Titan's surface, this ocean would be completely sealed beneath the ice, hidden from sunlight and isolated from the surface environment. The idea of a subsurface ocean immediately raises intriguing possibilities. On Earth, wherever liquid water exists, life seems to find a way. Deep beneath our oceans, ecosystems thrive around hydrothermal vents, independent of sunlight and powered by chemical energy. Similar environments elsewhere in the solar system could potentially support microbial life, even in complete darkness. Titan's internal ocean may not resemble Earth's oceans exactly. Mixed with ammonia, it would remain liquid at lower temperatures, creating a cold but potentially stable environment where chemical interactions could occur over long periods of time. Whether such an environment could support life remains unknown, but the possibility makes Titan one of the most compelling targets in the search for habitable environments beyond Earth. Yet Titan presents an even more unusual possibility, because while most discussions of life focus on liquid water, some scientists have proposed that entirely different forms of life could theoretically exist within Titan's methane lakes, using hydrocarbons instead of water as a solvent. On Earth, all known life depends on liquid water. Water acts as a universal solvent, allowing complex chemistry to occur within cells and enabling biological processes to function. But Titan challenges this assumption, presenting an environment where liquid methane and ethane take the role that water plays on our planet. Some researchers have explored the possibility that life could exist in Titan's methane lakes using entirely different biochemical processes. Instead of water-based cells, hypothetical organisms might rely on membranes made from hydrocarbons, forming structures capable of functioning at extremely low temperatures. While such life would be fundamentally different from anything we know, theoretical models suggest that certain chemical reactions could occur within these liquid environments. This idea remains speculative, and there is currently no evidence that life exists on Titan's surface. The extreme cold would slow chemical reactions dramatically, making the emergence of life far less likely than in warmer environments. Yet the presence of abundant organic molecules, stable liquids, and complex chemistry keeps Titan firmly within the realm of possibility when scientists consider alternative forms of habitability. At the same time, Titan's subsurface ocean offers a more familiar environment, one where liquid water could provide conditions similar to those found beneath the icy crusts of moons like Europa or Enceladus. If life exists within Titan, it may be hidden deep beneath the surface, protected from the harsh cold above. Whether Titan hosts life or not, it expands our understanding of what environments might be capable of supporting biology. It challenges the assumption that Earth-like conditions are the only path to habitability, showing that the universe may be far more diverse than we once imagined. And in that sense, Titan is not just an unusual moon. It is a reminder that worlds can evolve in ways that blur the line between familiar and alien, between environments that resemble Earth and those that operate under entirely different rules. From orbit, Titan appears calm, a soft orange world wrapped in haze, drifting quietly around Saturn. But beneath those clouds lies a landscape shaped by rivers, lakes, and weather, a world that feels strangely familiar at first glance. And yet, every detail reveals how different Titan truly is. Its rivers flow with methane instead of water. Its ground is made of ice as hard as rock. Its seas exist in temperatures colder than any natural environment on Earth, and its chemistry unfolds under conditions far removed from the warmth we know. Titan shows us that familiar landscapes can emerge from entirely different ingredients. It challenges our understanding of what makes a world Earth-like, revealing how diverse planetary environments can truly be. Whether life exists on Titan or not, this moon expands our perspective. It reminds us that even within our own solar system, there are worlds that blur the line between the familiar and the unknown. Join us next time as we explore more mysteries of the universe.